So this is question number 3 of homework 5. What are the prices of a call option and a put option with the following characteristics? Stock price is $91 per share, exercise price is $90 per share, risk-free rate is 4.1% per year, compounded continuously, maturity is 4 months. Because we know the maturity needs to be in years, we need to convert this into the years. Our standard deviation is 52% per year. So we're going to use the Black-Scholes option pricing model to calculate the value of the call option. Then we're going to use the Put-Call Parity to figure out the value of the put option. So we start from putting all the information down to Excel file. And starting from the stock price, which is the S stock price, that is the S here. So this is $91 per share. So just put that number down. And exercise price, this is capital E. So the price here is $90. And the risk-free rate, so that is R. This is little r, and so this is 4.1%. And maturity, which is expiration, that is capital T. This will be in, so this is 4 months, right? So we know we need to convert this into years. So we need to divide this by equals 4 divided by 12. That would be in number of years now. So we just put this in years. And standard deviation. So that's the sigma, right? Standard deviation. That's the sigma. And this is 52%. So we start from getting that E, D1, right? We know that if you go back to the next slides, the Black-Scholes model, we need to get this D1 first. D1 is logarithm of S over E plus R plus sigma square divided by 2 and multiplied by capital T and divided by this sigma times square root of capital T. So we just need to get that number first. So this equals, I add a parenthesis, and the reason I add a parenthesis is because I want to get the sum of these two first before I divide by the sigma and square root of capital T. So I'm going to use the logarithm function ln and open that. It's going to be S divided by E. So S is 91 divided by E, exercise price, and close that. And then sum, add this, and open that parenthesis, R plus sigma. Sigma is right here, standard deviation, square, and divided by 2, close this parenthesis. So far I'm here now, and then multiply by capital T. And close this, and then divided by sigma. Sigma is right here. And then I can just add a parenthesis before sigma because I want to divide by the product of sigma and square root of capital T, right? So, but you can also write to divide by sigma and then divide further by square root of capital T. So, yeah. And then don't forget we need to close this parenthesis. So this gives us D1. And we can further calculate D2, right? D2 is right here. D2 equals D1 minus sigma times square root of capital T. So this equals D1 minus sigma times square root of capital T. So this is basically D2. Yeah. So now I need to get N D1, the CDF of D1, or the interpretation of this N function is that it is the probability of a random variable, and that random variable is normally distributed. It's a standard normal with a standard normal distribution, and that random variable is less or equal than D1. So the N D1 stands for the probability of that random variable being less or equal to D1. So I can use this NORMSDIST function, right? NORMSDIST function. This will give me the CDF of a standard normal distributed function. So this, you can see there's only one argument z. You can just put this d1 as so this will give me the n d1. And then I can also get this nd2, right? Just pull the drag the cell down to get that. So now I have both nd1 and nd2 calculated. I can just simply plug in this formula to get this option, the value of the core option. So the C now equal to S stock price multiplied by simply plugging this formula, right? S multiplied by this ND1 and minus this E exercise price multiplied by this EXP, which is this little e here. That's the base of the natural logarithm function. And that will open that. It's going to be R, which is the risk-free rate, multiplied by this capital T. Close that. And then further multiply by this ND2 right here. So this gives me the value of the core option. And for the put option, I can just use the Put-Call Parity to figure out the put option value. So this is the Put-Call Parity. The put option price plus the stock price equals the core option price plus the e, little e raised to the power of negative r multiplied by capital T multiplied by and then close that and multiply by the exercise price. So from this, we can solve out P equals C plus this E raised to the power of negative R capital T times E minus S. So I'm going to use this equation to figure out the put option price. So this will equal to C plus EXP and raised to the power of negative R multiplied by so it's R multiplied by T, right? And close that. So and then multiply by capital E, which is the exercise price, and finally minus this stock price, right? Stock price. So this gives me the put option price. And then going back to connect to check the rounding requirement. Do not round to intermediate calculations and round your final answers to two decimal places. I guess that's exactly what we did, right? The core option price and put option price are both rounded to two decimal places. So I just need to copy the value back, and don't forget to get rid of the dollar sign because we already have a dollar sign in front of this blank. So we do the same for the put option price, copy that number down, and then check my work. So this is correctly done. um,